In this video, I'm going to show you how to use some of the functions in Excel to describe a set of data. So in our Excel sheet, I have some data, and I believe this data represents the ages of a class that I had a couple semesters ago. So you can see that I had students from 17 up to 44 years old. So one of the things that you often want to find out is the mean or the average of a set of data. And as you know from reading the PowerPoint, the average, you find it by adding up all the data points and then dividing by however many you have. So in this case, what we could do is we could add up all the points. Let's see, there are 24 of them, and then we could divide by 24. And that's a good way to do it. But with Excel, there's actually an easier way by using the average function. So the way I'm going to do this is I'm just going to go in my blank cell, and I'm going to type in equals average, and then a parenthesis, and then all you have to do is highlight your data, close parenthesis, and hit enter. And Excel adds it all up, and it divides by the total number, and we see that the average age is 22 years old. So looking down at the list, it's actually 22.29, so it's somewhere down in here. And what's interesting about the average is that it's very affected by outliers. In this set of data, we have one student who's 44, and they were significantly older than the rest of the class. You could almost include the 32-year-old as an outlier, but really the 44 is far away from the rest of them. I would consider that the true outlier. But what happened by having a bunch of students in our upper teens and 20s, and then one that was 44, is it pulled the average up. So 22.29 is probably 2/3 of the way up the data. You see how it's pulled towards the bigger number, and it's not really in the middle of the data set. So that shows how outliers can affect the value of the mean. My personal favorite way to describe the center, which I know it's pretty nerdy to have a favorite measure of center in statistics, but I do. I'm a math major, so I guess you could say I'm nerdy. But my favorite is the median. And what the median does is it splits the data exactly in half. So it's like you're counting from the outside in, and you're trying to figure out which point is exactly in the middle. And you could do this yourself. You could say, all right, I've got 17 and 44, and then 18 and 32, and then 18 and 29, and kind of work your way in. Or, again, we can use Excel. We can type equals median, parenthesis, and then we can highlight our data, and close parenthesis, and then hit enter. And Excel finds the median of the data for us, which is really nice. And as you know, if you're trying to find the median of a set of data that has an odd number, the median is just that single value that's in the middle all by itself. But if you have an even number of data points, the middle is actually two numbers that share the middle, and the median is the average of those two middle values. And Excel knows to do that. Excel knows to find whatever's in the middle and average it to find our median. And in this case, if we look at our data, see, we actually have 24 data points, so that tells us the median is going to be in the middle between 12 and 13. Let's see if I can find it right quick. Let's see, there's 12, so there's my top 12 data points, and then my bottom 12 data points. So the median is actually, I'm just going to box these in, it's actually found by taking the two middle numbers, which are 20 and 20, and averaging them. But if you take 20 plus 20 and divide by 2, you get 20, which is why it looks like our median is just 20. But that's not a single value. It actually did come from averaging. It just happened that those two numbers that shared the middle were both 20. But what's nice about the median is it's right here at 20. You see it's exactly halfway in the middle. We have 12 points above it, and we have 12 points below it. And that's why I really like the median, because it's not affected by the outlier. This value that's 44, let's say we changed it to 32 again. You see, it affected the value of the mean, but it didn't affect the value of the median. The median is not affected by outliers. I'm going to put it back at 44. But we can easily see that the median does not care if that bigger number is 44 or if it's 104. It's exactly the same, but the mean is affected. So standard deviation tells us about the spread of the data. And I'm going to use it with the stdev function. Just type it in and then highlight your data, close parenthesis, and hit enter. And that finds for us the standard deviation of the data, which basically tells us how spread out is the data. So if we take our mean of 22 and we go 5 standard deviations below, so if we go 22 minus about 5, that's what, about 17, 16, 17? And then one standard deviation up, which would be 22 plus about 5, which would be about 27. Most of the data is in there. And most of the data is in between those two values. If you take your mean of 22 and subtract the standard deviation, and then your mean of 22 and add the standard deviation, most of the data is going to be in between those two values. So I just kind of rough estimated that doing mental math, but you can get the idea that most of the data is between about 22 minus 5.8 and 22 plus 5.8. Okay. So another thing that we like to use is the 5-number summary, which just gives us 5 numbers that tell us a lot about the data. And the 5-number summary is made up of the minimum, the median, the maximum, and then what we call our lower quartile and our upper quartile. So the minimum is just the smallest number. We could look at our list and see it's 17, or we could type in equals min, highlight our data, close parenthesis, and hit enter. And similarly for our max, we could look at our list and see it's 44, or we could find the max of the data. And if your data wasn't organized, you'd probably want to use the min and the max data function. Since our data is already organized, it doesn't really matter. And then to find the median, we've already found it above, but if we wanted to remind ourselves how to find it, we just do equals median, highlight our data, close parenthesis, enter. So we know it's in the middle, but since it's an even number, we know that it's actually in between the two 20s. So what the lower quartile does is it describes the top half of the data. It gives us the number that's halfway in the top half. So the way we find it is we find the median of our top half of data. And I am going to include that 20 that shared the middle because the median is actually in between them. And it's a little awkward since they're both 20s, but the median splits the difference. So we want to include that in our top half. So if we find the middle value of the top half, that gives us our lower quartile. And then if we find the median of the other half, that gives us our upper quartile. So we see that 19 represents the middle of the top half of the data, so somewhere in here, and that 23 represents the middle of the top half of data. I guess 19 is for the bottom half and the 23 is for the top half. Excel thinks we made a mistake with these little green boxes, but we didn't. That's fine. Sometimes Excel thinks it knows better than we do, and sometimes it's right, but most of the time it's wrong. So again, what these quartiles tell us is where about a quarter of the data lies. So on our chart, we have about 25% of our data between the values 17 and 19. We have about 25% between 19 and 20, another 25% between 20 and 23, and then another 25% between 23 and 44. And because our initial numbers, the 17, the 19, and the 20, and even the 23, those are all close together, that tells us that we have a lot of data in those values. But going from 23 to 44 tells us that there, for some reason, that upper quartile is really spread out, and there's probably an outlier to make it go from being very, very close numbers to all of a sudden be much higher. So sometimes you can pick out outliers by looking at the values in your 5-number summary. So that's an overview of Excel. There are other ways to do these functions. You can use what's known as the function wizard button, which I didn't demonstrate in this video, but you get to it by going to the FX. And I know there's other ways. If y'all have a different Excel style, as long as you get the same final answer, I don't really care how you do it in Excel. I was just trying to show you one way that I think is pretty simple, so those of y'all that are new to Excel can see how we do it.